So in this video, we're going to be moving on from graphing conics to solving quadratic systems. So this past month, so essentially this entire quarter, we've been looking at quadratic functions and quadratic equations, and now to top it off, we've done quadratic equations that are conics, so we've done all of our graphing. And so now we're going to move beyond that, and we're going to go into solving quadratic systems. And there really isn't much to quadratic systems. The methods we use at the beginning of the year, so substitution and linear combinations, to solve linear systems is what we're going to use with quadratic systems. So the biggest difference here is that now instead of having linear systems, that means, two lines being used in the system, we're going to use quadratic systems. So we could have any conic and find solutions between the intersections of the two, okay? So a key thing to note though is that you can get complex answers, right? But we only want real solutions. So even though we can get complex answers, we're only going to take the real solutions. So let's look at an example. Number 4, we're given the two equations, y squared equals 2x and x squared plus y squared is equal to 8. And what I did is I graphed it if you look to the right on the screen. Okay, so the blue graph is y squared equals 2x. And the red graph is the circle x squared plus y squared equals 8. And if you notice, there are two intersecting points here. So we should get two answers. And that's why it's useful to kind of graph it so you get an idea of how many answers you should get. And so when we're going to solve this, we could either do linear combinations. We could reorganize it to try and solve it equally. Or if you notice, the first equation they gave us is y squared equals 2x. So we're going to substitute in for y squared in the second equation. So we're going to get x squared plus 2x equals 8. So we put 2x in for y squared because that's what it's supposed to be equal to. And then we can subtract 8 from both sides. And we can factor. So we get x plus 4, x minus 2, x equals negative 4 or positive 2. Okay, and so then remember, with system of equations, your answer should be in a point format. So if x is equal to negative 4, then y squared has to be equal to 2 times negative 4, so negative 8. But negative 8 would not give us a real solution, yes, because it's negative and it's supposed to be equal to a square. So that's not going to give us any answers. So then we look at if our second possible, which is x equals 2, then y squared is equal to 2 times 2, which is 4. So when we solve for y by taking the square root of both sides, so y is equal to plus or minus 2. So our possible answers are 2, 2, and 2, negative 2. And that's our answer. Let's look at a different one now. In 14, we're given x squared plus 2y squared is equal to 12, and 3x squared minus y squared is equal to 8. So unlike in 4, where we were given an equation that was already set equal to one of our y squareds, we don't have that this time. So this time we're going to do linear combination instead. So I'm going to multiply the second term by 2, the second equation by 2, so that I can cancel out my y's and solve for x. So I'm going to get x squared plus 2y squared equals 12, and 6x squared minus 2y squared is equal to 16. My y squareds cancel, and I'm left with 7x squared equals 28. So x squared is equal to 4, so x is equal to plus or minus 2. So then we're going to plug in each answer into one of the equations. I would say plug it into the first one, so that's what I'm going to do. So if x is equal to 2, then 2 squared plus 2y squared is equal to 12. So 2y squared is equal to 12 minus 4, which is 8. Y squared is equal to 4, so y is equal to plus or minus 2. So we get two answers, 2, 2, and 2, negative 2. But that's only for if x is equal to 2. Now we got to test if x is equal to negative 2. we've got negative 2 squared plus 2y squared is equal to 12. So 2y squared is equal to 12 minus 4, which is 8. Y squared is equal to 4. Y is equal to plus or minus 2. So our other two answers are negative 2, 2, and negative 2, negative 2. And so in total we have 4 answers here. And if you look at the graph that I have at the right top of the screen, that should make sense, because if you look closely, we've got an intersection there, intersection there, intersection here, and intersection there. Okay, so 4 possible points, 4 answers. Okay, let's look at one more. Let's look at 20. So for 20, it says y equals x squared minus 1, and the second equation they gave us was x times y plus 6 is equal to 0. Now this one's very different from the other two, because the first graph we were given was a parabola. As you can see in the graph, the orange is our first equation. But the second equation they gave us was x times y plus 6 is equal to 0. And so that graph is the black one, which looks very different from any of the other conics we did. And we did touch on this briefly in the first quarter, okay? So if we're looking at the graph, we only have one intersection right there between the black and the orange. So we should only get one answer, but it's gonna be a lot of work to get there. So what we're gonna do is we notice that y is equal to x squared minus 1. So we're gonna plug that in for y in our second equation. So x times x squared minus 1 plus 6 is equal to 0. We distribute that x, so we get x cubed minus x plus 6 is equal to 0. Here's where the tricky part comes in. This is a cube, and you can't factor by grouping, right? Because there's not 4 terms, there's only 3. And you can't easily factor anything out. So we have to do synthetic division, which we did at the beginning of the quarter. So we set up our synthetic division bar. We've got 1, 0, because there's no x squared, negative 1, and 6. And we need to figure out what can we possibly use to test these values. Remember, that's the second constant, the last constant divided by the factors of the first term. So that's the factors of 6 divided by the factors of 1. So we can get plus or minus 1 can work, plus or minus 2, plus or minus 3, and plus or minus 6, right? So we've got 8 possible choices to use for our synthetic division. Let's start off by using 2, okay? So we try 2, we bring down the first term, multiply 2 times 1, that's 2, 0 plus 2 is 2, 2 times 2 is 4, negative 1 plus 4 is 3, 2 times 3 is 6, which is 12. That's not equal to 0, right? So that's not one of my solutions, so I'm going to go ahead and cross that out. And now let's try a different number. Okay, so let's try negative 2. So we bring down the 1, negative 2 times 1 is negative 2, 0 minus 2 is negative 2, negative 2 times negative 2 is 4, negative 1 plus 4 is 3, negative 2 times 3 is negative 6, so that's 0. That does equal 0, so that means that negative 2 is a factor. So if we were to take out a x plus 2, right, because we changed the sign, we would be left over with x squared minus 2x plus 3. And then that quadratic that we just got out from the quotient is not factorable, so we'd have to use quadratic to solve. So that's 2 plus or minus square root 4 minus 12 over 2, which is 2 plus or minus square root of negative 8 over 2. This would not be any real solution, right? So our only possible answer is x equals negative 2. And so then we just need to plug that back into our very first equation, which was y squared equals y equals x squared minus 1. So if x equals negative 2, y is equal to negative 2 squared minus 1, which is 3. So our only possible intersection is negative 2, 3. Okay? So now that we've looked at quadratic systems, the next part of this is to look at word problems involving quadratic systems. And so the key thing to remember with these is the hard part is solving for the word problems and finding out what we have, what we don't have, and what we're trying to solve for in the first place. And then from there, it should let you fall back into that pattern that we just did in the last 3 slides. Okay, so let's look at the first one. Number 2. It says the product of 2 numbers is 1 and the difference of their squares is 15/4. Find the numbers. Okay, so the things that they want us to do, we need to find the numbers, right? So let's name those x and y. And then first thing they tell us is the product of x and y has to be equal to 1. So x times y equals 1. That's literally the first, 6 words. And then it says, and the difference of their squares is 15/4. So difference of their squares. So we've got x squared minus y squared has to be equal to 15/4. Okay, and so now we've got our two equations, and we're going to solve it just how we did before. So what I'm going to do is I'm going to rewrite the first equation as y equals 1/x to solve for one of my variables, namely x, and then I'm going to plug that in for y in my second equation. So I get x squared minus 1/x quantity squared equals 15/4. X squared minus 1/x squared is equal to 15/4. I'm going to multiply everything by 4x squared to get rid of my denominators. And so I get 4x to the 4th minus 4 equals 15x squared. I'm going to subtract 15x squared from each side. And then I'm going to factor this. So I end up getting 4x minus plus 1 times x minus 4 equals 0. And that should be 4x squared, and x minus 4. Okay, so my possibles are 4x squared equals -1 or x squared equals 4. Again, we only want real possible solutions, and 4x squared equals -1 is not going to be real, right? Because a quantity squared equals a negative number means we're going to have a complex number. So there's no real solutions from this first equation. So we're only going to solve the second one, so x is equal to plus or minus 2. We're going to plug that in for y up here. So that means that if x equals 2, y equals 1/2. And if x equals -2, y equals -1/2. So our possible numbers are 2 and 1/2 and -2 and -1/2. And those are our answers. Okay? Let's move on to 6. 6 says, find the length of the legs of a right triangle having perimeter 56 meters if the hypotenuse is 25 meters. So we want to find the legs of a right triangle. And so what's going to be beneficial for us on this one is to create an image. And it's a right triangle. So I'm going to draw a right triangle to the best of my ability. 1, 2, 3. Okay? And it says we want to find the legs, right? So that would be here and here. I'll name those x and y. And then they said that the hypotenuse was 25. So a couple of things to remember about right triangles. That means that if we can find all 3 sides of the triangle using the Pythagorean theorem, yes? So that means that x squared plus y squared has to equal 25 squared. We also know that the perimeter has to be equal to 56. So x plus y plus 25 has to be equal to 56. So I'm going to simplify each of those. That means that x squared plus y squared is equal to 625, which is 25 squared. And then x plus y has to be equal to 31 because I'm going to subtract 25 from each side. Okay, and so then from there, I'm going to solve for one of my variables in my second equation. I'm going to solve for y. So y is equal to 31 minus x. And then I'm going to plug that in for y in my first equation. So x squared plus 31 minus x quantity squared is equal to 625. That means that x squared plus 961, that's 31 squared, minus 62x plus x squared is equal to 625. And if you're wondering how I got those numbers in the middle, that's because I FOILed. Okay, right? You can't distribute that power. And then I'm going to subtract 961 from each side and combine like terms. I'm going to get the 336 back on the other side. Then I notice they all have a 2 in common, so I'm going to divide everything by 2 to get rid of it, so I can use simpler numbers. So I get x squared minus 31x plus 168 is equal to 0. This does factor. The factors are 24 and 7, so x minus 24 times x minus 7 is equal to 0. So x must either be 24 or 7. And so then, if we have one, we can always find the other, right? So we're going to go take these two numbers and plug them each one at a time into our first equation. So we get that if x is 24, then y has to be 31 minus 24, which is 7. And if x is equal to 7, then y has to be equal to 31 minus 7, which is 24. So my legs are 24 centimeters and 7 centimeters. Okay, let's look at 8. It says, find the dimensions of a rectangle that has area 10 and a diagonal of length 5. Leave your answer in terms of radicals. Okay, so first thing we're going to do is I'm going to draw a nice little rectangle for us, so we have an image to work from. Okay, so there's our rectangle. It has an area of 10 and a diagonal of length 5. So I'm going to draw a diagonal on this. Okay, this has to be equal to 5, and area of this entire shape has to be equal to 10. So that means that formula for area of a rectangle is length times width, and that has to be equal to 10. And then, like right triangles, rectangles have 90-degree angles at each of its corners, right? So that means that we can create a triangle, a right triangle, with the diagonal and then 2 of the sides. So we've got that the hypotenuse has to be 5, and then the legs have to be L times W, right? Because that's what we used before. So L, W. So that means that length squared plus width squared has to be equal to 5 squared, which is 25. And I've got my two equations. I've got length times width equals 10, and length squared plus width squared is equal to 25. So I'm going to solve by dividing both sides by L. So W is equal to 10 over L. And so then I'm going to plug that in for W in my second equation. So I get that L squared plus 10 over L quantity squared is equal to 25. L squared is equal to 100 over L squared equals 25. I'm going to multiply everything by L squared to get rid of my denominator. So I get L to the 4th plus 100 equals 25 L squared. So that means that L to the 4th minus 25 L squared plus 100 has to equal 0. I'm going to factor this into 20 and 5. So L squared minus 20 times L squared minus 5 is equal to 0. So L must either be plus or minus square root 20 or plus or minus square root 5. Now remember, we're dealing with length because this is a rectangle, so negative values will not be considered, right? So L is either square root 20 or square root 5. And so when I reduce those, I get 2 root 5 or root 5. And I'm going to plug that into my first equation up here that I solved for W. So if L is equal to 2 square root 5, then W has to be equal to 10 over 2 root 5, which when we rationalize, right, to get rid of the radical in the denominator, we end up with 5 root 5 over 5, which is equal to root 5. And if L is equal to root 5, then W is equal to 10 over root 5, which is equal to 10 root 5 over 5, which is equal to 2 root 5. So our dimensions are square root 5 by 2 root 5, or vice versa, 2 root 5 by square root 5. And there are new units on this one, so if you want to be specific, add units at the end. Okay? All right, last problem. This is a bit involved, so stay with me on this. 4 squares, each with sides 4 centimeters long, are cut from the corners of a rectangular piece of cardboard having area 560 centimeters squared. The flaps are then bent up to form an open top box having volume 960 centimeters cubed. Find the dimensions of the original piece of cardboard. So the way I'm thinking of this image, if I had a 3D model to work with, is I think of like an open pizza box. Okay, so first thing they tell us is that there are 4 squares, each with sides 4 centimeters long, cut from the corners of our rectangular piece of cardboard that you see at the right. So I'm going to add in some corners here. So 1, 2, I'm trying to make them even, but it's a little hard, 3 and 4. And so what's left over is this dotted piece of cardboard in the middle. This will form the bottom of our box, right? Okay, and each of these rectangular pieces has a length of 4 centimeters on each side. So in truth, we're cutting 4 from each side, right? So 4 from here and 4 from here. That means that we're cutting out 8 centimeters in total, right? 4, 4, and 4. Okay. So that means that our original length of our cardboard is here, and our original width is here. And then this new width on the inside has to be width minus 4, and length minus 4, or length minus 8, and width minus 8. Okay? So let's figure out what else they gave us. They told us that the area has to be 560 centimeters squared of the original cardboard piece. Okay, so that means that length times width is equal to 560 because that's what it used to be. And then the flaps are then bent up to form an open top box having a volume 960 centimeters cubed. So now the volume has to be using the new dimensions after we cut away the corners. So that's going to be W minus 8 times L minus 8 times H, because formula for volume is length times width times height. It has to be equal to 960. And so from here, we can solve for our dimensions of our original piece of cardboard. So what we're going to do first is I'm going to simplify the second equation as well as the first. I'm going to solve the first for nothing. I'm actually going to keep it because if I distribute my 2 parentheses here in the second equation, I get L times W minus 8L minus 8W minus 64 times H has to be equal to 960, right? And the only thing we're missing is H here. But the nice thing is that H, the height of each of the box itself has to be 4, because when we fold those flaps up, remember they had a length of 4 to begin with. So we actually are going to multiply all of this by 4. So we get 4 times LW minus 8L minus 8W minus 64 is equal to 960. And I'm going to divide both sides by 4 to get rid of it so I don't have to deal with huge numbers. Right? And so I end up that L times W minus 8L minus 8W minus 64 is equal to 240. Okay? And so then if you notice, the very first term of our equation, LW, has to be equal to 560 according to our first equation. So we're going to plug in that 560. So we get that 560 minus 8L minus 8W minus 64 has to be equal to 240. And so when we simplify, we end up with negative 8L minus 8W is equal to negative 384. And so what I'm going to do is I'm going to divide everything by negative 8. And so I end up with L plus W is equal to 48. And I'm going to solve this for W, so that I can plug this into my first equation and solve for an actual answer. So W is equal to 48 minus L. And I'm going to plug that into L times W equals 560. So L times 48 minus L is equal to 560. So 48L minus L squared is equal to 560. I'm going to move everything over to the right. So 0 is equal to L squared minus 48L plus 560. And then I'm going to factor this into L minus 28 times L minus 20. So L is either equal to 28 or 20. And so then I need to plug that into this first equation for W right there. So if L equals 28, W equals 48 minus 28, or 20. And if L equals 20, W equals 48 minus 20, which is 28. So my dimensions are 20 centimeters by 28 centimeters, or 28 centimeters by 20 centimeters. Okay, and that was it. All right, so that's the lesson. The classwork is not due until Thursday and Friday because, again, we have a half-day schedule on Wednesday. All right, so classwork for C block is due on the 16th, which is Thursday, and the 17th, which is Friday for F block. And it's page 441, numbers 1 through 19 odd, and the problems numbers 1, 3, 5, 9, and 12. 1 and 3 are like the first word problem I did, 5 is like number 6, and 9 and 12 are similar to 8 and 10 respectively. Okay? And I hope everyone is having a lovely Valentine's Day tonight.